Okay, hello all. This is your recording for the week before Thanksgiving. I thought it was going to be short, but it looks like it might be kind of long. So you may have to pause me partway through and take a break. When I went back and looked at the syllabus, I guess I was supposed to hit theory of constraints last week and transfer pricing this week. When I went through, neither of these is super difficult, so I think we're fine. Theory of constraints. Developed to help managers reduce cycle times and operating costs. So cycle time, it's like your operating cycle. It's the amount of time between when you get the customer order and when the order is shipped. So it's the time for the product to be manufactured. So it can include the amount of time it takes to get the raw materials in and the production process. What you're looking for are constraints or bottlenecks in the production process. So these are going to be the activities in the manufacturing process that slow things down. So really what is going to determine, or what are the big points in the manufacturing process, are the points where everything backs up, because that's what's going to hold up uh, the the production when you're running at full speed, or the steps where things are backing up, the steps that take the longest. So the constraints are where you want to focus. Um, so for your final, one of the things on this theory of constraints that you need to know are the 5 steps in the theory of constraint analysis. The best way to do this is to create a workflow document. So you want to look at all the steps in the process and document those out. So if there's a series of assembly lines that are consecutive in manufacture, so one's happening after the other, you need to know every step in that process and how long each one takes. So if those can be operating at the same time, you need to know what step in each of those processes takes the longest. Where are things going to be piling up? And you need to deal with that. So he has a nice diagram, or actually it's the reading materials that you have before you actually go into the lecture, that does a nice diagram of this. So you have the exhibit 13-7, the flow diagram for HPI. That does a nice explanation of this, because you have the electronic component. So you have the assembly of the earpiece, then you have the computer chip that goes into the other hearing aid. So that has an additional step that the simpler hearing aid doesn't have. Um, so you do have to look at how long each of these processes takes, add up the total time altogether, and that's how you diagram this out. So if your job is to plan out, so this is part of the process of being the budgeting the time or planning out the project. If you're a project manager, this is what you're doing. So it's part of being the manager of the facility is being the project manager. I mean, this is part of the job of being a project manager, is planning out the production process. So you have to understand how far ahead do the raw materials have to arrive at the factory so that the production steps can happen in a timely manner. Um, the other thing you want to think about is, if the inspection has to happen 25 days, or it takes, so long for the inspection to happen, the first inspection has to happen far enough ahead so that the production that takes place after that inspection is done before the date of delivery. So you have to work backwards. So we're trying to sell my mother-in-law's house, and we need to do some repair work on it, and we're trying to have it listed April 1st, and I keep trying to tell the in-laws, well, if we want it listed April 1st, we have to go back, and so the house is going to have to be empty by, March 1st, because we have to get it listed and have the realtors look at it, and that means, you guys have to have picked everything up, or people have to have, arranged to have vans there to pick everything up by, let's say, the beginning of February, because there's going to be hiccups in that process, which means you have to decide who's taking what by the beginning of January, which means, we have to have all this repair work done, which is going to take 2 or 3 months, which means we have to decide on what things we're getting done, repair work, and get that all booked and started now if we plan on having this listed April 1st. So you can't be sitting around at this point, not doing anything yet. If we want to have this listed April 1st and we're, working back in time, we can't wait any longer to be making these decisions. So you're working back in time to say what has to happen by which date if you want to have everything completed by this date in the future. So this is something you need to know, these 5 steps for your final exam. Tack time, this is a tool that can be used along with drawings of where you work your way back in time to figure out the beginning date. So like I said, if you know you need you need 90 days after you hit this approval date. So if the electrician has to approve things, and after the electricity is approved, you need 3 months to do the finishing work. So you have to work backwards 3 months, and the approval has to be done. The electrician approval has to be 3 months prior to you expect to have the people move in. So you have to go back 3 months in time, and then before the electrician's work can be done, you have to have the walls finished, or you have to have the step before that has to be completed, and you can estimate, well, how much time will it take us to get to the point when the electricity work can be approved, and you can work back a step in time. And there's a good example of that in the reading materials, which was, let me see if I can find it, Exhibit 13A.1. So that was a nice visual of that method. The tack time, they don't call it that directly when they're doing it. There's a question on your final exam, and you don't have to officially use this equation at the top, the total time available divided by expected demand. You can really just convert it all into the same period of time, and that works just as well. But it's this idea that the slowest process in the production process is going to create the constraint. So it's really just stating all the activity or all the units per minute to meet the demand. So if you want to have 10,000 units produced at the end, or you have 24 hours of time, how many units are produced, you need to put everything in terms of 24 hours and see if you have the same number of units. And if you don't have the same number of units, the one that has the smallest is going to be the constraint. So this is just a matter of saying, if you have 24 hours of time and your demand is a certain number, can you meet the demand? That's a different way of looking at it. So this one says you have this many hours, this is your demand. Do you have enough time to meet the demand, or do you have excess time? Or the other way to look at it is can you reach the required demand in the time you have available or not? And so you're looking to see, well, which specific process are you unable to meet the demand you have, and that's going to be the constraint. Again, the flow diagram, that's the one where you visually look at how much time each step requires and what point in the process the step starts, and is there enough time after you have each step taking place that you are completed before the due date. So these are all different tools you can use in the manufacturing process to make sure you're going to meet your due dates. The drum buffer rope system is the only particular system that they talk about in your final exam. So really, I kind of went through this and looked at the big topics that were final exam questions. So I'm sort of preparing you for final exam because we don't have a quiz on this. And the drum buffer rope, it's really the rope, and then you have a buffer with the drum beat. So what they do, the illustration is some kids on a hike, and the leaders have a rope attached to them, and that keeps them from getting too far ahead. And you put the slowest person in the middle, and the rope is tied to the slowest person, and the slowest person drums out a beat with their footsteps. And so the people in the front can't get too far ahead of the slowest person, so their rope is kind of maybe pulling them along, but also keeping them from getting too far ahead. So if they stop, the person tied to the rope is going to catch up to them, and they know that when they're getting close, because the rope gets too slack, and they'll hear the drum getting louder. And because the person who's the slowest is beating the drum to their footsteps, the people that are behind them can keep in step with them, and they'll know where they are, so they aren't going to walk up on their heels and override them, or get right up on their back and be too close. So the idea is that the people in front of them aren't going to go tearing off way into the future and lose them, and the people on behind aren't going to be walking up their back and having too much on top of them, so they won't be pressuring them. So if you have this kind of a system, you don't have the people in the front being idle for long periods of time and out of step with everybody coming behind, and the people behind aren't building up too much inventory so that things end up with a huge backlog. So that's the concept of this. So this is the example that we're going to do for this problem, just to get you working through it and giving it a try. And we have two products here that we're working. So the first one is REC1, the second one is REC2, and what you see here is that REC1 has the receiving step, and it's got two materials that go into it. It has a machining step, an assembly step, and a finishing step. Okay. And then REC2 has two materials in it. It has a receiving step. There's two assembly steps and a finishing step associated with it. And we have our total minutes available here, our total machining minutes available, our total assembly minutes, and our total finishing minutes. All right, so when we go to our next page, here's our information. So our demand for REC1 is 100 units. Our demand for REC2 is 60 units. And our cost, our selling price is $450 for REC1 and $600 for REC2, and that was given to us up in the text at the top. The materials cost, so material A for REC1 was $60. For material B was $150, giving us a total of $210. And for REC2, material B was $150, material C was $150, giving us the $300. So that's our basic information in the materials cost. So our first activity, receiving, they told us that we had time available of 60. our time requirement for REC1, we had two different times for receiving. So we had the 10 minutes plus the 25, giving us a total of 35. REC2, we just had the one, which was the 25 minutes. For machining, we only had the one for REC1 that was 85. No machining for REC2. Assembly for REC1, we just had the 30 minutes. REC2, we had the 30 minutes plus the 15, so that gave us the 45. REC1, we had 60 minutes of finishing, and REC2, we had 40 minutes of finishing. So this gives us all the information about the time required for each of the different products per unit. Now our step one, we need to identify the constraint. So these are the 4 steps we need to go through. So the first one, let's identify the constraint. So this requires us to take the demand for the product and multiply it by the time required for each unit. So for the REC1, we need 35 minutes of receiving time per unit. So 35 minutes times 100 units. So here's our work rate here. So we've got the 10 plus 25 receiving times 100 units is 3,500 units. For REC2, it's 25 minutes times 60 units. Okay, so that gives us 1,500. So the total time required for receiving for the 2 units is 5,000 minutes, and we have 6,000 minutes available. So there is slack time in the receiving department. For machining, 80 minutes times 100 units, so we have 8,000 minutes, and we have 10,000 minutes available. So we have some slack time in the machining department. For assembly, we've got 30 minutes per unit times 100 units, or 3,000. For REC2, we've got the 30 plus 15, or 45 minutes per unit times 60 units that are demanded, or 2,700. So a total of 5,700 minutes required, but the time available is only 5,000. So we have a constraint here because there's more time demanded than is available. So that's a problem. And in finishing, 60 minutes times 100 units is 6,000. 40 minutes times 60 units is 2,400. So total requirement of 8,400. Available 10,000. So we have slack time in finishing. So it looks like our only constraint right now is in the assembly department. So now we're going to go look at just the assembly department, because once you have your constraint identified, you're going to focus on just the constraint. You're going to ignore everything else, and you're going to elevate the constraint. So what we have to do is identify the most profitable product. So we're going to look at the most profitable product, and then we elevate that to deal with the constraint. So now our focus is to look at the 2 products and calculate the throughput for the product for the constrained activity. So for REC1, when we do throughput, all we want are the direct materials. We don't care about anything else. And this is because this analysis was calculated by a physicist instead of an accountant. And when the physicist did the initial formulation, he didn't have an accounting background. And so he assumed all the costs except for the direct materials were fixed. And that's really what drives the whole thing. So we're going to take the price per unit, which was $450 for REC1, minus the direct cost. So it's price of $450 minus the direct material of $210, which gives us throughput margin of $240. And then we're going to divide that by the minutes, or the constraint that we identified. So the constraint we identified was the assembly. So for assembly, for REC1 was 30 minutes. So we divide by 30 minutes, and that gives us $8 of throughput time. So this is similar to what we were doing in the last chapter, the chapter before, where we were looking at the contribution margin. So we were trying to figure out the contribution margin per the constrained material, and we did all of the variable costs. In this, though, we're looking at the contribution margin per constrained throughput, or for throughput rather than contribution margin. So we're just looking at the direct material when we're doing throughput. Before, we were looking at the contribution margin for constrained, it was constrained activity, I believe. So this one, we're dividing by the time. It was but dividing by time, and it's $8 of profit for the constrained process that we're looking at. So for REC2, our direct material cost is $300. So we have a $600 price, $300 direct material cost. So we have a throughput margin of $300. Our assembly takes 45 minutes per unit. So we have a throughput per minute of $6.667. So we gain more profit by working on REC1. So it's more profitable to work on REC1. So we would spend time completing our order for REC1 before we spend time working on REC2. So our order for REC1 is 100 units. So what we want to do is complete the 100 units. So it's 100 units times 30 minutes, which is 3,000 minutes. So 3,000 minutes we'll work on first. And for assembly, we have available 5,000 minutes. So if we work on we use 5,000 minutes, there's 2,000 minutes left. And REC2 takes 45 minutes. So we have 2,000 minutes remaining. If we divide by 45 minutes per unit, we will be able to complete 44 units of REC2. So we'll be able to complete 44 units of the other model of the hearing aid. So we'll complete 100 units of model REC1 hearing aid, and then 44 units of the REC2 hearing aid, and that will provide us the largest amount of profit we can make from the machinery and the workers that we have available. So that's step 1 and step 2. Step 3 in the process, so we've maximized the flow through the constraint. Step 4 would be to add capacity to the constraint. So usually what you'll do is either increase the number of workers you have, or figure out a way to increase the speed that the work can be done, increase the design, or change the design so that the assembly can happen faster or more efficiently. After that has been done, you will redesign, that's redesigning the manufacturing process for flexibility and fast cycle time. So that would be number 5. And then you basically go back to 1 and re-identify what the new constraint is. So every time you fix one constraint, something else becomes the new constraint. Okay, transfer pricing. So transfer pricing is just the exchange price for products within an organization. So it's selling things to yourself. It's moving product between one part of the company and another part of the company. It has implications when parts of your organization are in different countries. So it has issues from repatriation of profits perspectives. It has implications for labor issues between different countries because there's differences in the way workforces are treated, particularly between Japan and the US. It has major tax avoidance issues. So when things are taxed at much higher rates in the US, international income versus Ireland, there's issues when tax is taxed at a higher rate in, say, New York State versus Nevada or New Jersey. So they'll try to shift the taxable income from one state to another. So that's why this transfer pricing is a highly controversial issue. There's 6 major transfer pricing methods, and pretty much the method you use is, or the price you use is dictated by the situation you're in. It's kind of a logical, there's a logic behind what price you use, and it's based on what is going to be to the most to the benefit of one of the parties. So if the selling division is if the selling division, they have to make a profit, or they have to at least cover their variable costs because they can't afford to be selling it for less than their variable costs, because it's not to the benefit of the managers of the manufacturing department to transfer it to another part of the business for less than their variable cost, because it's going to impact their personal evaluation. So they're not going to transfer it to another department for less than their variable cost. So that's going to be the minimum selling price in the short run. If for the selling unit, in the long run, they're not going to be willing to sell it for less than the full cost of the manufacturing price, because they want to cover at least their base cost. I mean, they don't want to be selling this at a loss for the long run. And it doesn't make sense for the company to be accruing a loss. They want to be covering at least their costs. I mean, one department's got to cover the other department, and it doesn't make for sense for one department over the long time to be reflecting a loss and the other department to be carrying the gain. So if you think about it, why would you have one department showing a loss while the other department is getting the benefit of the gain? It makes no sense to have one part of your company showing that it's performing badly and having the other department reporting a false positive that it really doesn't have. That's really kind of foolish. So at a minimum, over the long term, if this is going to be a continuing, ongoing thing, you would want it to transfer at the actual cost. So you would want it to transfer at the minimum, the selling cost, the actual cost of the manufacture of the product. If the market price, so if the unit can be sold to an outsider, so if there is demand that the product actually can be sold to the outside, the selling unit isn't going to accept something less than the sales price. So if they're giving up sales to an outside party, the seller isn't going to agree to sell it to the company at something less than the true sales price, because why would they cut their profitability for the benefit of the company? So the market price is going to be the minimum sales price if the department that's making the product can sell it to a third party. So they're not going to be willing to sell it to or transfer it within the company if they can have a profit by selling it to a third party. So the actual sales price would be the minimum if there is enough demand that the manufacturer can sell it outside. If the department that needs the product can go outside of the company and buy it for something less than the manufacturer is selling it to the outside, then the amount that the purchaser can buy it for outside of the company will be the maximum transfer price. So why would they pay themselves? Why would they transfer it between the two divisions at the higher sales price to the outside rather than the amount that they can go outside and buy it for? So it's always going to be, the lowest transfer price that's possible. But the unit that's manufacturing it isn't going to decrease their profit to benefit some other division within the company if it's going to make their profits lower, because the managers of the manufacturing division are getting compensated based on their profitability. And they're not willing to give up their bonuses. And the managers of the buying portion of the company are getting their bonuses based on their profitability. So they're both looking for the best. That's why sometimes you have 5 and 6, which is where the management will come in and say, forget it, we're going to negotiate this. You guys are just being idiots. And you're both fighting about this, and you're hurting the company as a whole. So we're going to come in and we're going to negotiate it because you're just both being stubborn. And we're going to come in and say, look, this is the price you're transferring it at. So, because sometimes they just the company is better if they say, look, this is the agreed on price, and this is what you're going to do it at, because there isn't something exactly the same, or the level of quality isn't high enough, or they're going outside the company and it's causing problems, or for some other reason they want it to be transferred within the company, and the different divisions aren't working it out. So they'll come in and just say, nope, this is what it's transferring at, and this is how you're going to do it. So the bosses come in and do it. But usually they don't do that unless there's, some new company that's been acquired, or there's some initiative that they're trying to make happen. So, and I think